Hello students, welcome to CMI's online classes, and today we will discuss chapter number 14, chemical effects of electric current, or we can say electric current and its effects. So as we all know, electricity is most vital or most important form of energy, and we use in many places, as for example at home, at office, and in factories also. Okay, so today we are going to discuss some chemical effects. So let's start the topic. So first of all, we have to learn, or we have to know few components which is very much essential for electric conduction. Okay, first here we have electric components on the left hand side, and on the right hand side we have some symbols given which will help us for understanding the topic. So number one is electric shell, that we call a battery. Okay, and the symbol is given on a right hand side. Then we have electric bulb, small one. Okay, not a big one, because small cell or small battery can only help a small bulb to glow, not a big one, not a larger one. And we have a symbol on the right hand side. Similarly, when switch is in off position, that means this pin is not connected. Another one, when switch is in on position, that means the metal or the pin, we can say aluminum pin or silver pin, whatsoever, okay, it is attached. Then we have a larger battery for better conduction, and at last we have a wire, because wire is essential for conducting electricity or flow of electricity. Okay, so these components and their symbols are very much essential to understand the topic. Then let's talk about one by one. We have electric cell. It has a positive terminal and a negative terminal. That means one end is positive and the another end is negative. The symbol of an electric cell has a longer line and a shorter line. The longer line is the positive terminal and the shorter line is the negative terminal of an electric cell. Okay, so as we discussed electric cell, okay, so it has a positive terminal at one end and negative terminal at another end, and a longer line is used for positive terminal and shorter line for negative terminal. Now let's move to battery. A battery is the combination of two or more cells. That means electric cell is a single cell, and a battery has two or more cells. In a battery, the positive terminal of one cell is connected to the negative terminal of another cell. Okay, so devices like torches, transistors, toys, TV remote control uses batteries. So we can also see the combination of two or more cells in our remote TV remotes, or in bigger torches. Okay, so two or more, either two or three batteries are connected, and these are connected as we can see in the lower left hand corner. Three batteries are connected of 1.2 volt. Negative is connected to positive, and then again to negative, then positive, then negative, then again positive, and last both are connected to either a bulb or some other appliances. Okay, then we have on a right hand side we can see a figure where two battery cells are connected. Okay, the lower one is connected to the upper one, and on the right hand side two wires, one of black color and one of red color, are attached, and that can be attached to any electric appliances or battery appliances. Okay, now we will move further and look at a simple electric circuit. A simple electric circuit can be made by using a cell. That means a single cell, one electric bulb, switch, and wires. Wire is necessary. Okay, just see here, a bulb glows only when the switch is in the on position and the circuit is closed. That means a circuit is said to be closed when the switch is on and open when the switch is off. Okay, and during off or in open circuit the bulb doesn't glow, whereas in a closed circuit the bulb glows because flow of electricity is not broken in closed circuit. Here we can see a figure, a battery cell which has a positive terminal and a negative terminal, and one wire is attached to a positive terminal towards one end of switch or the pin. This pin can be used as a switch, and from the negative one wire is attached to one terminal of a bulb. Okay, and another terminal of the bulb, a wire is attached to a pin, that is a switch, and when this is connected the bulb starts glowing. That means to lit a bulb or to bulb, if we have to glow a bulb, what we have to do? We have to connect all the wires. Okay, so we have a figure of closed circuit and an open circuit. Then let's move to another part, that is heating effect of electric current, how it works. Okay, so when electric current flows through a wire, the wire gets heated. This is called heating effect of electric current. That means whenever we put a plug in a socket at a home, okay, so what happens? The electric current flows through the wire, and wire are actually made up of conductors, okay, aluminum or silver, okay, but we don't feel the heat of the wire. Why? Because outer portions, a plastic covering or an insulator is used. Okay, and this flow of wire causes heating effect. So let's have an activity here. Make an electric circuit as shown in the figure. Take a 10 centimeter long nichrome wire, that means any form of wire, okay, and tie it between the two nails. That means we have to take two nails, okay, and we have to tie that wire to the both the end of the nails. Then switch on the current. After a few seconds, touch the wire. Okay, the wire feels hot. That means the wire becomes hot. And don't do it with your home electricity appliances. It's just to explain you. Okay, then switch off the current. After a few seconds, touch the wire again. It does not feel hot. That means wire becomes heated. This shows that when electric current flows through a wire, it gets heated. Okay, you can do this experiment using a battery cell, because battery cell doesn't have such power to give us a shock. But don't do it with our home wiring or home electricity. Okay, so you can perform this activity using a switch, with your battery cell, a single battery cell. Okay, so you can just observe that when current is flown, okay, when switch is on, the wire gets heated, and when it is off, it is cool. Okay, then let's move to another part, uses of heating effect of electric current. So where does that effect applies? The heating effect of electric current is used in electrical appliances like electric heater, electric iron, electric room heater, immersion heater, electric kettle, hair dryer, etc. That means they are an example of direct electric current, flow of electric current. Okay, all these appliances have a coil of wire called an element, or you can say filament also. Okay, when electric current flows through the elements, it becomes hot and gives us heat. Okay, we have a good example of iron. So in iron, electric iron, when you switch on the light, what will happen? The base of an electric iron becomes hot and we can use it. Okay, and if it is off, again it becomes cool. So these are the good example of flow of electric current or heating effect of electric current. So the amount of heat produced in a wire depends upon its material, length and thickness. Okay, so material, which material is used, what is the length of the wire, and what is the thickness of the wire. So talking about the wire, so it is made up of different materials. Length can be different, even thickness. Some are flexible wire which is of low resistance, some are of 1.5 mm, some are of 2, some are of 0.75 mm, okay, some are of 4 mm. So these are the thickness of a wire and they depend that what amount of heat is consumed. Okay, then we will move towards another part, that is electric fuse. So electric fuse is a safety device used in electrical circuits which protects the electric circuits and appliances and prevents fire. That means it is like a safety valve. Okay, it's like a safety valve. So electric fuse is used in all electric circuits in building so that there is no short circuits or any other defaults in electricity. Okay, so electric fuse has a wire which melts quickly and breaks with large electric current flows through it. That means the current that flows at our house sometimes fluctuates, sometimes higher amount of electricity flow, and that can harm our home appliances like TV, fridge, okay, bulbs, etc. So to prevent it from such a large amount of flow of electric currents, we use fuse. So here we have a picture of fuse. A fuse has a wire attached to both the end. Okay, then if such type of flow occurs, that means of high voltage, what will happen? This wire melts, and if this wire is cut off, as we know, it's an open circuit, and due to this there is no flow of electricity. Okay, only we have to change the wire of a fuse later on when the situation becomes normal. So this was all about electric fuse. Then we will talk about magnetic effect of electric current. So when electric current flows through a wire, it behaves like a magnet. Obviously, when it is heated, it behaves like a magnet. That's why when we touch a naked wire, okay, where electricity is flowing, we also get attached to it. So this is called magnetic effect of electric current. So let's have an activity here. Take the cardboard tray from a matchbox. Okay, wind an electric wire a few times around the cardboard tray. That means you have to wind it or roll the wire. Then place a small compass needle inside it. Okay, just put what you can put, a needle, okay, in a box. Okay, and when the switch is on, the compass needle deflects. That means it will move. When the switch is off, the compass needles come back to its original position. That means it will be back. This shows that when electric current flows through a wire, it behaves like a magnet. Okay, you can do this experiment also, or the activity also. Then we have electromagnet. Okay, so here also we have an activity. When electric current is passed through a coil of insulated wire wound round a piece of iron, it becomes a magnet. Such a magnet is called an electromagnet. So let's have an activity. Wind a piece of insulated wire. That means just roll a wire in that iron nail in the form of a coil. Connect the free end of the wire to an electric cell. That means battery cell of one battery cell, through a switch. You can make a switch by a pin. Then place some pins near the nail. When electric current is passed, the iron nail becomes a magnet and attracts the pin. Okay, you have to just keep the pin aside. When electric current is switched off, the nail loses its magnetism and the pin drops. Okay, again switch on, the pin is attached. Again switch off, the pin will drop. Okay, it will not be attached to a iron nail. So this experiment can be done with a battery cell. Okay, so they will move towards electric bell. An electric bell also function similarly as an electromagnet. Here, electric bell has a coil of wire wound around a piece of iron which acts like an electromagnet. An iron strip with a hammer is kept close to an electromagnet. There is a contact screw near the iron strip. Okay, when the iron strip is in contact with the screw, current flows through the coil and becomes an electromagnet. We will discuss with the figure. It pulls the iron strip and the hammer at the end of the strip strikes the gong of the bell and produces sound. When the electromagnet pulls the iron strip, it also breaks the circuit and iron strip comes back to original position. And the process repeats and the bell rings. Just see, on the left hand side is a original view of a electric bell. On the right hand side we have a function here. Just see, switch which is on the right hand side and a battery is attached. When this iron horn or north and south is placed, okay, they have a contact, and after the contact the striker strikes the gong. Okay, gong means the metal part. Okay, as we can see in the bell of cycles. Okay, it is like a bell of a cycle. When that is heated by the striker, it starts ringing. So it is a simple diagram of a electric bell. And at last we will have a conduction tester. How conduction is tested? Okay, a conduction tester is a device used to determine whether a substance is a good or poor conductor of electricity. Let's see. Sometimes the current flows through the circuit may be too weak and the filament of the bulb may not get sufficiently heated to make it glow, as I talked earlier. Okay, if we light a 100-watt bulb with a battery, it will not glow. Okay, that requires a huge amount of energy. So then, instead of a torch, a bulb and LED can be used in a circuit. Okay, LED glows even when a weak current flows in the circuit. So LED has the capacity. LED bulb has the capacity to glow in a very weak current flow also. Okay, so this help us to test the conduction of electricity. Here we have a figure. Okay, so negatively charged and positively charged battery cell, and when it is attached, if the LED bulb glows, then it has a good resistance. Okay, that means it is a good conductor of electricity. Okay, we can test it by LED bulb. So this was all about chemical effect of electric current. So thank you.